Earth is 4.5 billion years old. From orbit to night, our cities flicker like fleeting sparks against the cosmic dark. Tokyo glows for a mere century. Rome shimmers for 3,000 years. The pyramids endure for 5,000. Together, they are less than a heartbeat in the planet's vast timeline. We tell ourselves a story of this world. Stone tools gave way to bronze, bronze to iron. Writing emerged 5,000 years ago in Mesopotamia. History began. All that came before. We call primitive silence, yet Earth keeps its own records. Ice cores from Antarctica trap air bubbles from 800,000 years ago. Fossil bones in Africa reveal humans like us, with our brains and hands, living 300,000 years ago. What did they create in that immense span of time? This is a thought experiment, not a claim. Any discovery would demand rigorous verification. Consider this. Our tallest towers would crumble to dust in 10,000 years. Our highways would vanish beneath forests in 1,000. Even Mount Rushmore would erode to smoothness in 100,000 years. Göbekli Tepe, a 12,000-year-old temple in Turkey, lay buried until a farmer's plow struck stone there. If such a marvel could hide for millennia, what else might await discovery? If there were statues before ours, where are they now? If there were signals before ours, on what frequency did they travel? The ocean floor conceals valleys once walked as dry land. Ice sheets veil continents unseen. Earth recycles its surface like a slow, relentless machine. Could an advanced civilization have risen and vanished hundreds of thousands of years ago? What if we are not the first? Modern humans have walked Earth for 300,000 years, yet we've recorded our story for only 5,000. That leaves a vast silence of 295,000 years. Not empty, but erased by time's relentless hand. The ocean floor whispers of this erasure. Every 200 million years, plate tectonics recycle it entirely, raising mountains from seabeds and swallowing them again. Geologist John Zalasievich calls this the planet's metabolism. Archaeologist Colin Renfrew reminds us, absence of evidence is not evidence of absence. We seek three faint signals in deep time. Chemical traces in rock layers, like the iridium spike marking the dinosaur-killing asteroid 66 million years ago. Air bubbles in Greenland's ice cores, preserving breaths from 800,000 years past. Submerged coastlines, where ancient rivers carved valleys now drowned. Each signal is fragile, easily mistaken for natural noise. True discovery demands multiple, independently verified threads. During the last ice age, glaciers locked so much water that sea levels fell 400 feet, exposing land as vast as a vertical Manhattan. Cities built on those coasts 100,000 years ago would now lie beneath waves. The ocean is patient, erasing all memory, yet ice preserves what water destroys. In Greenland, scientists drill through frozen time, finding ash from eruptions long forgotten. In sealed caves, minerals encase ancient secrets. In ocean depths, sediments pile grain by grain. These are Earth's hidden archives, rarely opened. Time erases most pages, but some endure, waiting for us to read. Modern humans have walked Earth for 300,000 years, yet our written records span only 5,000. History textbooks trace a tidy path. Hunter-gatherers roamed for millennia. Agriculture emerged 12,000 years ago. Cities rose 6,000 years ago. And and writing began 5,000 years ago. Before that lies prehistory, a term that dismisses 295,000 years, as if nothing worth noting could have happened. But we share the same brains, hands, and the capacity for language as those early humans. What were they building in all that time? The timeline we know reflects not what happened, but what survived. Stone tools endure. Bones sometimes persist. Metal leaves faint traces. Wood rots in decades. Leather fades in centuries. And even stone carvings blur in 10,000 years. Our history is a map of durable materials, not a record of all that was. Consider your own life, your digital photos, electronic messages, and maintained homes would vanish in 1,000 years. Carve your name in stone today, and by the year 7,000, wind and rain will have erased it. Now imagine that loss stretched across 100,000 years. This is a thought experiment, not a proven claim. Survivorship bias clouds our view. We see only what lasts, not what was lost. True discovery requires multiple verified lines of evidence, uncontaminated by misdating or error. Yet the question persists. Why assume a civilization began only in the last blink of Earth's 4.5 billion year story? Earth's records dwarf ours. Complex life spans 600 million years. Mammals, 200 million, primates, 55 million. Yet we assume technology emerged only recently because that's where our evidence stops. Absence of evidence, as archaeologist Colin Renfrew notes, is not evidence of absence. Take Göbekli Tepe, a 12,000-year-old temple in Turkey, discovered by chance when a farmer's plow struck stone. It upended our timeline, revealing complex structures before agriculture was thought possible. Or consider the Antikythera mechanism, a Greek device from 100 BCE with gears so intricate it stunned scholars. If one ship carried such sophistication, what sank with others? We are pattern seekers, drawn to stories of steady progress from primitive to advanced. But Earth counts in millions, not thousands. The ground beneath you may once have been ocean floor or mountain peak, recycled by time's vast machinery. Troy, once deemed a myth, revealed 9 layered cities when Heinrich Schliemann dug where others saw nothing. What might lie hidden in the 300,000 years we call prehistory? Our methods: carbon dating for 50,000 years, potassium argon for older samples, rely on clear artifacts. But what if those artifacts dissolved? What if they were crafted from materials we mistake for natural? In museum vaults, mislabeled relics may wait. The fossil record, capturing less than 1% of all species, reminds us how much slips through time's fingers. We may be rediscovering, not discovering what came before. The past is silent not because it was empty, but because time consumed its traces. Tomorrow, we ask when civilization truly began. What makes a civilization? We usually say cities, writing, monuments, and metal tools, but that definition might be our biggest blind spot. Anthropologist Robert Carnero at the American Museum of Natural History pointed out that the Inca built an empire without writing. They used knotted strings called quipu instead. The Aboriginal Australians navigated a continent for 50,000 years without cities. They had songlines instead of maps. Were they not civilized? Civilization might be simpler than we think. It might just mean people organizing beyond family groups to solve complex problems together. That could happen with or without stone monuments. It could happen with or without metal. The Amazon rainforest teaches us this lesson. For decades, we thought it was pristine wilderness. Then, archaeologist Anna Roosevelt found evidence of large settlements along the Amazon dating back thousands of years. No stone pyramids, no metal tools, just sophisticated earthworks and enriched soils called terra preta. These Amazonian societies modified entire forests. They domesticated plants we still eat today. They built raised fields and fish weirs. They connected settlements with road networks. At their peak, millions of people might have lived there. Then European diseases arrived in the 1500s. 90% died. The forest reclaimed everything. If not for new laser surveys that see through the canopy, we would never have known. This is crucial for our thought experiment. If complex societies can thrive without leaving obvious monuments, how many have we missed? Archaeologist David Wengrow from University College London argues that we have been looking for the wrong things. We search for palaces and temples. But what if ancient peoples organized differently? What if they built with bamboo and earth? What if their greatest achievements were social, not architectural? Consider this fact. Writing has existed for about 5,000 years. Modern humans have existed for 300,000 years. That means 98% of human existence happened before anyone wrote anything down. We call this prehistory. But that assumes nothing important happened. What if important things happened, but in forms we do not recognize? We must be cautious here. Definitions matter in science. Category errors lead to false conclusions. Any claim about ancient civilizations needs testable predictions and multiple lines of evidence, but our current categories might be too narrow. We define civilization by our own reflection: agricultural, urban, literate, monumental. What if those are just one way to be complex? The Pacific Northwest peoples had complex societies without agriculture. They had permanent settlements based on salmon runs. They had elaborate art and rich mythology. They had social hierarchies and long-distance trade. By some definitions, they were not civilized. By other definitions, they were. The definition itself becomes the problem. Time plays tricks with evidence. A wooden city can be as complex as a stone one. But after 1,000 years, only the stone remains. We find the stone city and declare it the first. But was it really, or was it just the first to build in materials that last? This is not mere speculation. We keep finding earlier dates for known innovations. Agriculture was thought to begin 10,000 years ago. Now we find evidence from 15,000 years ago. The oldest known temple is Göbekli Tepe in Turkey, 11,000 years old. But notice the word known. Before its discovery in 1994, we would have said temples began 6,000 years ago. One discovery moved the date back 5,000 years. What else are we wrong about? What other dates will move when we dig deeper? Here is what haunts me about these numbers. Homo sapiens has existed for 300,000 years. We have evidence of symbolic thought from 100,000 years ago. Cave paintings, jewelry, burial rituals. These require abstract thinking, planning, culture, the same cognition that builds civilizations. Yet we insist civilization waited another 95,000 years to begin. Does that seem likely to you? The academic consensus is cautious for good reasons. Extraordinary claims require extraordinary evidence. False positives waste resources and confuse the record. But extreme caution can also blind us. If we only look where we expect to find things, we will only find what we expect. The Amazon settlements were there all along. We just had to learn how to see them. Memory is fragile. Writing helps, but writing can be lost. The Maya wrote thousands of books. Spanish colonizers burned all but 4. The Library of Alexandria held centuries of knowledge. Fire took it all. Even with writing, civilizations can vanish from memory completely. Without writing, they vanish even faster. We are left with a troubling possibility. The 5,000-year story of civilization might be wrong. Not completely wrong, but incomplete. Like a book with most of its pages missing. We read the surviving pages and think we have the whole story, but we do not. We have the pages that happen to survive. The rest is silence. Silence does not mean absence. Now let us see what Earth looked like in deep time, 100,000 years ago. The world map looked wrong. During the last ice age, so much water was locked in glaciers that sea levels dropped by 400 feet. That is taller than the Statue of Liberty. Imagine draining the ocean by that much. Suddenly, vast territories appear. Britain connects to Europe. Alaska connects to Siberia. Indonesia becomes a continent. The Persian Gulf is dry land. These were not barren wastelands. They were coastal plains with rivers, forests, and grasslands. The space between current-day islands in Southeast Asia was a landmass twice the size of India. Scientists call it Sundaland. 2 million square kilometers of territory that supported megafauna and possibly humans. All of it is underwater today. We know more about the surface of Mars than about these drowned lands. Ice sheets covered much of North America and Northern Europe. The Laurentide ice sheet was 2 miles thick over modern-day Canada. Its weight was so enormous it pressed the continental crust down hundreds of feet. The land is still rebounding today, rising a few millimeters per year. Stockholm gains new land every generation. Hudson Bay gets shallower every century. The planet remembers the weight of ice, but ice was not everywhere. Large parts of Siberia remained ice-free despite brutal cold. The Sahara alternated between desert and grassland on cycles of 20,000 years. The Amazon basin might have fragmented into forest islands separated by savanna. What seems permanent to us shifts like sand to the planet. Mountains that exist today were seafloor then. Seafloor then might be mountains in another 100 million years. The ocean floor itself tells this story every 200 million years. The entire seafloor recycles through plate tectonics. Ocean crust forms at mid-ocean ridges. It spreads outward like a conveyor belt. Eventually, it plunges back into the mantle at subduction zones. Nothing on the ocean floor is older than 200 million years. The continents are older, but they too get reworked. India slammed into Asia 50 million years ago. The collision is still happening. Everest grows taller every year. We must be careful with these timescales. Dating uncertainties grow larger the further back we go. Regional differences matter enormously. While ice covered New York, humans might have thrived in Southeast Asia. While the Sahara was green, Northern Europe was tundra. The planet has many climates simultaneously. Any claim about global conditions needs regional verification and multiple dating methods. Rivers also played different songs. The Mississippi has changed course many times. The Amazon once flowed backward into the Pacific. The Nile has dried up completely several times. When rivers move, civilizations must move or die. The Indus Valley civilization might have collapsed when monsoon shifted. The Mayans might have fallen to drought. Water writes history, then erases it. Here is something that troubles me. During glacial periods, the best land was the coastal plains, rich soil from river deposits, moderate climate from ocean buffering, abundant seafood, and fresh water. These are exactly where humans tend to build cities today. Tokyo, New York, Mumbai, London, all would have been inland during the Ice Age. The prime real estate was what we now call the continental shelf. Marine geologist Glenn Milne from Durham University has mapped these lost landscapes using seismic surveys and sediment cores. He can see ancient river channels beneath the North Sea. He can trace coastlines that have not existed for 12,000 years. There are hills and valleys down there, lakes and wetlands, perfect for human settlement, all drowned when the ice melted. The Black Sea tells a specific story. Until 8,000 years ago, it was a freshwater lake. Then rising oceans broke through the Bosporus. Salt water poured in with the force of 200 Niagara Falls. The lake rose 500 feet. Anyone living on those shores had to flee. Some researchers think this event inspired flood myths around the world. One flood, many stories, memory preserved in metaphor. If we accept that the best land is now underwater, we face an uncomfortable conclusion. Most evidence of Ice Age settlements is inaccessible. We would need submersibles and drilling equipment to find it. A few projects have tried. Archaeologists found mammoth bones and stone tools on the North Sea floor. Fishing nets have dragged up human skulls from the English Channel. These are accidental finds. Imagine what systematic searching might reveal. The exposed continental shelves were not small additions. They totaled about 20 million square kilometers. That is twice the size of Europe. If even 1% supported human populations, that is 200,000 square kilometers of lost territory. For comparison, Great Britain is about 240,000 square kilometers. We might have lost an area of human habitation equivalent to Britain, now sitting under hundreds of feet of water. Climate was different too. Carbon dioxide levels were lower. The atmosphere was dustier from exposed sediments. Winds were stronger. Storms were more intense. But in protected valleys and coastal areas, conditions could be quite comfortable. The Mediterranean climate existed, just in different places. What is now the Sahara had lakes and grasslands. What is now the Amazon might have been more open. The world was not uniformly hostile. It was differently arranged. This different arrangement matters for our thought experiment. If humans or their relatives developed complex societies, they would have done so in a world we can barely recognize. Their ruins, if any existed, would be in places we cannot easily reach. Under ice, under water, under millennia of sediment. The Earth has redecorated many times since then. The planet keeps its own schedule. Ice ages last about 100,000 years. Interglacials like ours last 10 to 20,000 years. We are living in a brief, warm intermission. For most of human existence, the world looked like the Ice Age world. Our current coastlines are the exception, not the rule. Continental shelves were humanity's front yard. Now let us meet who lived there 100,000 years ago. You were not alone. If you were Homo sapiens walking through Europe, you might meet Neanderthals. They had brains as large as yours. They made art, buried their dead with flowers, and cared for their injured. In Asia, you might encounter Denisovans. We know frustratingly little about them beyond their DNA. In Indonesia, Homo floresiensis stood 3 feet tall on the island of Flores. In Africa, other archaic humans whose names we do not yet know shared the landscape. This was not a world of one human type, but many. Each group had fire, each made tools, each survived ice ages and climate shifts that would challenge any modern society. The stereotype of the savage caveman is exactly that, a stereotype. These were people who navigated by stars, predicted seasons, and passed knowledge across generations without writing. How is that primitive? Look at what they could do. Humans reached Australia at least 65,000 years ago. This required boats capable of ocean crossings. It required navigation out of sight of land. It required planning and cooperation among groups. These were not accidents. You do not accidentally cross 90 kilometers of open ocean multiple times with enough people to establish populations. The Neanderthals tell their own story. At El Sidrón Cave in Spain, researchers found evidence of medicinal plant use from 50,000 years ago. Yarrow and chamomile, the same plants used medicinally today. At Bruniquel Cave in France, Neanderthals built stone circles deep underground 176,000 years ago. They arranged stalagmites in precise patterns. They maintained fires in complete darkness. Why? We do not know. But this was not random behavior. We must be careful not to overinterpret sparse evidence. Most sites give us only fragments, a few tools, some bones, traces of fire. From these scraps, we reconstruct entire ways of life. This is like finding 3 words from a book and trying to write the plot. Small samples lead to large errors. Every claim needs verification across multiple sites and time periods. But even being cautious, the evidence shows sophisticated minds. At a Blombos cave in South Africa, humans made paint 100,000 years ago. They mixed ochre with bone marrow and charcoal. They stored it in abalone shells. This is chemistry. This is planning. This is culture. The same site has geometric engravings on ochre from 75,000 years ago. Abstract symbols, the beginning of external memory storage. Consider what abstract symbols mean. A symbol stands for something else. It requires agreement on meaning. It requires teaching that meaning to others. It is a shared fiction that becomes real through belief. Every civilization is built on such fictions. Money, laws, borders, gods. If humans 75,000 years ago had symbols, they had the cognitive foundation for everything we have built since. Their social lives were rich without cities. Anthropologist Robin Dunbar at Oxford calculates that human brain size allows social groups of about 150 people. Beyond that, you need formal structures, hierarchies, rules, shared myths. The archaeological record suggests Ice Age humans had exactly such structures. Trade networks spanned hundreds of kilometers. Shell beads from the Mediterranean appear in sites far inland. Obsidian from specific volcanoes traveled thousands of kilometers from its source. These were not isolated bands wandering randomly. They had meetings, gatherings, exchange systems. At Dolní Věstonice in the Czech Republic, 30,000 years ago, someone made ceramic figurines, not pots for food, art for its own sake. The first ceramics we know of. They also made textiles. Impressions in clay show woven fabric from 27,000 years ago. These people were not naked savages. They were clothed artisans. The burial record reveals even more. At Sungir in Russia, 34,000 years ago, 2 children were buried in elaborate clothing. Their garments had over 13,000 ivory beads. Each bead took an hour to make. That is 13,000 hours of work. 1.5 years of labor for funeral clothes. This speaks to social complexity, hierarchy, belief in afterlife, investment in memory. Language must have been fully developed. You cannot coordinate mammoth hunts with grunts. You cannot teach bead making without grammar. You cannot navigate to Australia without words for wind and waves. Genetic evidence suggests the capacity for modern language evolved at least 100,000 years ago, possibly much earlier. The hardware was ready. The software was running. Yet we insist these people did nothing remarkable for most of their existence. 300,000 years of anatomically modern humans, 295,000 years of supposed wandering. Then suddenly, agriculture and cities. Does that trajectory make sense? Or are we missing something because we expect primitives and interpret all evidence through that lens? Here's what keeps me awake. Every human group we have ever studied has stories, songs, and complex beliefs. Everyone has rules and rituals. Everyone has ways of understanding the world that go beyond mere survival. Why would Ice Age humans be different? If their minds were like ours, their cultures might have been extraordinary in ways we cannot imagine. Ways that left no stone monuments, ways that dissolved into time. The people were ready. The minds were modern. Now let us see how Earth erases even mountains. The ocean floor tells us a truth we do not like to hear. Every 200 million years, the entire seafloor gets recycled into Earth's mantle, pulled down at subduction zones, melted, gone forever. If there were cities on the ocean floor from 200 million years ago, they are now part of the magma beneath our feet. Time does not just hide evidence. Time destroys it completely. But you do not need millions of years for erasure. 10,000 years is enough to remove almost everything humans build. Rain is patient. Each drop carries away a few molecules. 1 billion drops carve canyons. Frost is clever. Water seeps into cracks, freezes, expands, and splits the strongest stone. Wind is relentless. In the desert, it polishes granite into sand. In the Arctic, it grinds mountains into dust. Fire erases faster. The Library of Alexandria held 700,000 scrolls. Centuries of knowledge. One fire. And civilization forgot how to calculate the size of Earth. We had to rediscover it 1,000 years later. The House of Wisdom in Baghdad held 400,000 books. The Mongols threw them in the Tigris River. The water ran black with ink for months. Each time, we tell ourselves we will remember. Each time, we forget. Let me give you a thought experiment. Tonight, every human vanishes. What would remain of us in 100,000 years? The honest answer is almost nothing visible. Within 1 century, most buildings collapse without maintenance. Within 1,000 years, cities are forests. New York would look like Angkor Wat. Concrete crumbles, Steel rusts, glass shatters. Even Mount Rushmore would be unrecognizable within 10,000 years. Our satellites would fall within decades. Our roads would crack and be overgrown within centuries. Our dams would fail within millennia. Nature is infinitely patient and infinitely thorough. The Amazon would reclaim Sao Paulo. The Sahara would bury Cairo. The ocean would swallow Miami. We would leave a layer in the geological record: plastics, radioactive isotopes, changes in pollen, but no obvious monuments. This is where the internal skeptic must speak. Taphonomy, the study of how things decay and fossilize, is highly selective. We see only what survives, not what existed. Soft tissues vanish. Hard materials persist. This creates systematic bias in our understanding. A civilization that built with stone appears more advanced than one that built with wood. But is that true? Or is it just more visible? Consider what actually survives long term. Not buildings, not books, not bones. What survives are subtle signals: chemical changes in sediment layers, isotope ratios in ice cores, pollen distributions showing which plants were cultivated, charcoal layers indicating large fires. These signals are easy to miss. They look like natural variation unless you know exactly what to seek. The Antarctic ice cores show this perfectly. They preserve tiny air bubbles from 800,000 years ago. We can measure ancient carbon dioxide levels. We can detect volcanic eruptions from specific years. But these cores are only 800,000 years deep. The ice below that is compressed beyond readability, melted and refrozen too many times. Even ice forgets eventually. Caves preserve better than open air. But even caves change. Stalactites grow over paintings. Floods wash away sediments. Earthquakes collapse ceilings. Animals dig new tunnels. The few decorated caves we have found are miracles of preservation. For each one that survived, how many were destroyed? We will never know. Absence is invisible. Here is something specific that haunts me. We have stone tools from 2 million years ago. We have almost no wooden tools from before 10,000 years ago. This does not mean wood was not used. It means wood does not survive. If ancient humans made complex wooden machines, buildings, or art, we would have no evidence. The record shows us as stoneworkers because stone survives. It hides woodworkers because wood does not. Metals fare no better. Iron becomes rust within centuries. Copper corrodes to powder. Bronze develops patina, then crumbles. Gold survives, but is soft and rare. Aluminum would last longer, but extracting it requires advanced chemistry. A metal-using civilization from 100,000 years ago would leave only vague stains in the soil, elevated iron levels, unusual copper concentrations, easy to mistake for natural deposits. Even our most permanent markers are temporary. We have placed warnings on nuclear waste sites meant to last 10,000 years. We use symbols, pictures, languages, and a hostile architecture. But 10,000 years is nothing. Languages die in centuries. Symbols change meaning in generations. What looks like hostile architecture might become sacred architecture. Future humans might worship where we meant them to fear. The Anthropocene, our current geological age, will leave clear signals: plastic layers, nuclear fallout, extinct species, altered climate. But these signals are indirect. They say something happened. They do not say who did it or why. If humans vanished tonight and new intelligence arose in a million years, they might detect our chemical signature. But would they recognize it as artificial or explain it as a natural anomaly? Time erases everything eventually. Even mountains become sand. Now let us see where archaeologists can and cannot look. A farmer in Turkey was plowing his field in 1963 when his plow hit stone. He assumed it was a buried rock and worked around it. For 30 years, that stone remained untouched. Then archaeologist Klaus Schmidt arrived in 1994. That rock was the top of a 12,000-year-old temple, Göbekli Tepe, older than Stonehenge by 7,000 years, older than the pyramids by 8,000 years. We almost missed it entirely. This is the reality of archaeology. Most discoveries are accidents. A construction crew hits bones. A farmer finds pottery. A flood exposes ruins. We excavate less than 1% of known sites. We survey less than 1% of possible sites. The ocean floor, where sea levels were lower for most of human history, is barely touched. We are trying to reconstruct human history by looking at a tiny fraction of the evidence. Funding shapes where we look. Archaeological digs are expensive. A single season can cost hundreds of thousands of dollars. Grants go to safe bets, known sites, expected finds. Biblical archaeology gets funding. Egyptian tombs get funding. Prehistoric settlements from unknown cultures do not. This is not conspiracy. It is economics. But it creates systematic blind spots in our knowledge. Even when we do dig, we dig shallow. Most excavations go down a few meters, maybe 10 meters for important sites, but 100,000 years of sediment can be 30 meters down or more. Reaching those depths requires major engineering, shoring up walls, pumping out water, protecting workers. Few projects have the resources, so we study the recent past intensively and leave the deep past untouched. The ocean is worse. Marine archaeology requires ships, divers, and submersibles. A single day of ship time costs tens of thousands of dollars. Visibility underwater is often measured in centimeters. Currents scatter artifacts. Sediment buries everything. We have better maps of Mars than of our own seafloor. If an Ice Age civilization built on the continental shelf, we would likely never find it. Here is where the skeptic must be loudest. Cherry-picking anomalies is easy. Every field has outliers that seem to challenge the timeline. But science requires convergent evidence. Multiple lines pointing to the same conclusion. Independent replication across sites. Göbekli Tepe changed our timeline because it fit with other emerging evidence of early complexity. One side alone proves nothing. Consider what we have systematically ignored. The Amazon rainforest was thought to be pristine until recently. Then laser surveys revealed massive earthworks, geometric patterns, raised roads, settlements for millions of people, all invisible from the ground, all missed for centuries. We only found them because new technology let us see through the canopy. What else are we missing because we lack the right tools? The Sahara Desert is another blind spot. It was green and inhabited multiple times in the past 100,000 years. Lakes, rivers, grasslands, perfect for human settlement. Now it is the largest hot desert on Earth, 9 million square kilometers, almost completely unsurveyed archaeologically. Satellite images show ancient river channels, but sandstorms bury everything. A few meters of sand can hide entire cities. Siberia preserves but does not reveal. The permafrost can keep organic materials intact for tens of thousands of years, but the permafrost is melting. As it melts, preserved sites are destroyed before they can be studied. We are in a race against time. Every summer, irreplaceable evidence turns to mud. Local peoples sometimes find mammoth tusks or human remains. Most are never reported to scientists. The deep ocean trenches are completely unexplored archaeologically. These trenches formed over millions of years. If anything heavy fell into them, it would be preserved in the cold, oxygen-poor environment. But exploring trenches requires specialized equipment that costs millions. No archaeological project has that budget. So the trenches keep their secrets. Urban areas create another problem. London has been continuously inhabited for 2,000 years. Every new building destroys older layers. Every subway tunnel cuts through history. We get glimpses during construction. A Roman bath here, a medieval cemetery there. But systematic deep excavation is impossible. The city needs its land for the living, not the dead. This is structural suppression, not conspiracy. The structure of modern life makes deep archaeology nearly impossible. Property rights, development pressure, funding priorities, safety regulations, each reasonable on its own. Together they create a wall between us and the deep past. We see what is convenient to see. We miss what is expensive to find. Even our dating methods have limits. Radiocarbon dating works to about 50,000 years. Beyond that, we use other isotopes, but these require specific materials, volcanic ash, certain crystals. If a site lacks these materials, we cannot date it precisely. 100,000-year-old site might be dated anywhere from 80,000 to 120,000 years. 40,000 years of uncertainty. The pattern is clear. We look where we expect to find things. We find what we expect to find. We dig shallow because deep is expensive. We avoid oceans because land is easier. We study the recent because the ancient is uncertain. These are reasonable choices, but they create a map with most of the territory missing. Like drawing the world from an airplane window. You see what is below you. You miss everything else. If we started looking in new places with new methods, what would we find? The Amazon showed us. Göbekli Tepe showed us. Each time we look where we did not expect complexity, we find it earlier than we thought. The lesson is not that civilization definitely existed 100,000 years ago. The lesson is that we would not know if it did. We are archaeologically blind to deep time. Now scientists ask how blindness might be overcome. In 2018, two scientists asked a question that changed how we think about deep time. Gavin Schmidt from NASA and Adam Frank from the University of Rochester published a paper with a playful title, The Silurian Hypothesis, named after fictional reptiles from Doctor Who. But the question was serious. If an industrial civilization existed on Earth millions of years ago, how would we detect it? Their answer was surprising. Forget looking for ruins or artifacts. Those would be gone. Instead, look for chemical signals. Industrial civilizations change their planet's chemistry in specific ways. They burn fossil fuels, leaving carbon isotope spikes. They create synthetic molecules that never existed before. They spread radioactive isotopes from nuclear technology. These changes get recorded in sediment layers. The planet remembers in chemistry what it forgets in stone. Think about what our civilization is leaving behind. Not our cities, those will crumble. Not our satellites, those will fall. What survives is our chemical signature. Plastics that break down into microparticles, persistent organic pollutants that bind to sediments, a sudden spike in carbon dioxide levels, a layer of fly ash from power plants. These are the fossils of the industrial age. Schmidt and Frank were not claiming such a civilization existed. They were showing how to look for one. The method applies whether we are talking about 60 million years ago or 100,000 years ago. The deeper you go, the harder detection becomes. Sediment layers compress, chemicals degrade, isotopes decay. But some signals persist for millions of years. Here's where skepticism is essential. Natural events can mimic industrial signatures. Volcanoes release carbon dioxide. Lightning creates nitrogen compounds. Asteroid impacts spread unusual isotopes. Forest fires leave charcoal layers. To distinguish natural from artificial, you need specific patterns, global distribution, synchronous timing, concentrations above natural background, multiple independent markers pointing to the same date. The Paleocene-Eocene thermal maximum gives us a template. 56 million years ago. Global temperatures spiked by 5 degrees Celsius. Carbon isotopes shifted dramatically. The ocean acidified. It looks almost like an industrial signature. But it happened over thousands of years, not centuries. Too slow for industry. Too fast for normal geology. Scientists still debate the cause, but it shows how dramatic changes leave readable records. What would a civilization from 100,000 years ago leave behind? The signals would be subtle by now. Carbon spikes would have dispersed through the carbon cycle, but some traces might remain. Unusual metal concentrations where mining occurred. Synthetic molecules if they created plastics or similar materials. Radioactive decay products if they had nuclear technology. Agricultural pollens in places that were not naturally farmed. Fly ash is particularly interesting. When you burn coal at high temperatures, it creates tiny glass spheres full of trace metals. These spheres are distinct from volcanic ash. They form only in industrial furnaces. We are spreading billions of tons of them today. In sediment cores from the future, they will mark our era clearly. If ancient people had coal power, their fly ash would still be detectable. The problem is knowing where to look. Sediment accumulates unevenly. Some places have meters of sediment from the last century. Other places have almost none from the last million years. The best preservation happens in lake bottoms, river deltas, and deep ocean basins, places with steady deposition and little disturbance. But these are exactly the places we rarely core deeply enough to reach around 100,000 years ago. There is also the problem of resolution. A sediment layer might represent 1,000 years compressed into a centimeter. Industrial civilization has existed for only 2 centuries. Our entire industrial signature might compress to less than a millimeter. Easy to miss. Easy to mistake for a natural event. You would need to sample at incredibly fine scales to detect it. This connects to a deeper question. How long must a civilization last to leave a detectable signature? A century? A millennium? If high technology lasted only a few decades before collapse, would we ever find it? the shorter the duration, the fainter the signal. A brief industrial pulse might look like a volcanic eruption or forest fire. Only careful isotope analysis would reveal the truth. Schmidt and Frank calculated detection probabilities. For recent events within 10 million years, industrial signatures should be findable with current technology. For events beyond 50 million years, detection becomes nearly impossible. Signals blur, markers degrade, chemistry equilibrates. At 100,000 years, we are in the middle zone, possible but difficult, requiring luck and precision. The Silurian hypothesis shifts our entire perspective. Instead of looking for pyramids and pottery, we should look for chemistry and isotopes. Instead of digging for artifacts, we should analyze sediment cores. The evidence might already be in museum storage, cores drilled for climate research, samples taken for geology studies, sitting in freezers, waiting for someone to ask the right question. Memory is written in chemistry. Now we search for the library. Where would you hide something for 100,000 years? Not deliberately hide it. But where would the evidence naturally survive the grinding wheel of time? The answer is nowhere obvious. The best preservation happens in places hostile to life, cold, dark, oxygen-starved. These are Earth's accidental archives. They are also the hardest places for us to search. Start with the continental shelves. During the Ice Age, these were coastal plains, prime real estate for any civilization. Now they lie under hundreds of feet of water. But water can preserve what air destroys. In the Black Sea, ships from 2,000 years ago sit intact on the bottom. No oxygen means no decay. Wood still looks like wood. Rope still looks like rope. If older settlements exist in similar anoxic basins, they could be remarkably preserved. The Mediterranean has dozens of such basins, deep bowls where water does not circulate. The bottom layers have been without oxygen for thousands of years. Anything that sank into them would be preserved like a museum specimen. But exploring these basins requires remotely operated vehicles and precise navigation. One wrong move stirs up sediment and destroys visibility for weeks. Most have never been explored archaeologically. Antarctica holds different promises. The ice sheet is 3 million years old in some places. It grows layer by layer like tree rings. Each year's snowfall compresses into ice, trapping air, dust, and chemicals from that time. Scientists have drilled cores over 3 kilometers deep. These cores go back 800,000 years. They show carbon dioxide levels, volcanic eruptions, even forest fires from specific years. But here's what haunts me. Antarctica was not always covered in ice. 34 million years ago, it had forests. Even during recent ice ages, parts of the coast were ice-free. If people or their ancestors ever lived there, their traces would be sealed under kilometers of ice, preserved perfectly, completely inaccessible. We would need to melt the ice sheet to find them. The cure would kill the patient. Sealed caves offer another possibility. At Movile Cave in Romania, scientists found an ecosystem sealed from the surface for 5 million years. Blind spiders, transparent worms, bacteria that eat rock. If life can survive sealed for millions of years, so could artifacts. But most caves flood periodically. Water dissolves and redeposits minerals. Evidence could be encased in flowstone, transformed beyond recognition. We must acknowledge the access problem. These preservation sites are exactly the hardest places to study. Deep ocean requires ships and submersibles costing millions. Antarctica requires international cooperation and extreme logistics. Sealed caves might be toxic or radioactive. Each expedition risks contamination. One careless breath introduces modern DNA. One touch leaves skin oils. The act of discovery can destroy what we find. Lake beds tell their own stories. Lake Vostok in Antarctica has been sealed under ice for 15 million years. It is liquid because geothermal heat and pressure keep it from freezing. If we could sample its sediments without contamination, we might find records going back millions of years. But drilling through 4 kilometers of ice without introducing surface microbes is nearly impossible. 7 years of drilling, 20 years of arguments about contamination, still no clean samples from the bottom. The Atacama Desert in Chile is the driest place on Earth. Some areas have had no measurable rainfall in recorded history. NASA tests Mars rovers there because it is so lifeless. But that same lifelessness means perfect preservation. Mummies from the Chinchorro culture are 7,000 years old but look recent. If older artifacts exist there, they could be intact. But the Atacama is vast and hostile. Most of it has never been surveyed. Deep sediment cores from the ocean floor should contain chemical signatures from 100,000 years ago. Some cores already in storage might hold evidence, but analyzing them requires knowing what to look for. Elevated mercury from mining, artificial carbon isotope ratios, synthetic molecules that should not exist without a specific search pattern. Anomalies look like contamination or natural variation. There is also the problem of sparse sampling. We have deep ocean cores from perhaps 1/1,000,000th of the ocean floor. If an ancient civilization occupied even 1% of the planet, we would likely miss them entirely with current sampling. It is like looking for a specific sentence in a library by reading one random word from one random book. The odds are essentially zero. Contamination haunts every deep sample. Modern chemicals are everywhere. Plastics shed from equipment. Metals leach from drill bits. Diesel exhaust settles from ships. Distinguishing ancient synthetic signals from modern contamination requires extreme clean room protocols. Most cores were not taken with such care. They were drilled for climate research, not archaeology. Even identifying a good signal is challenging. What looks artificial to us might be natural to nature. What looks natural to us might be artificial to them. We assume industry means metals and combustion. But what if they had biotechnology beyond our imagination? Their artifacts might be indistinguishable from evolved organisms. We could be looking right at them and not know it. The preservation paradox is this: the best places to preserve evidence are the worst places to look for it. Under ice, under oceans, in toxic caves, in lifeless deserts. These places protected evidence by being hostile to discovery. Every year, technology improves. Robots go deeper. Sensors get better. DNA sequencing gets cheaper. But we are racing against time. Ice melts. Seas rise. Caves flood. What survived 100,000 years might not survive another 100. The archives exist. Accessing them is the challenge. Now we examine what might already be misfiled. The Antikythera mechanism should not exist. Pulled from a Greek shipwreck in 1900, it has bronze gears within gears. It calculates moon phases and planetary positions. It is more complex than any device we would see again for 1,000 years. But here's the crucial point. It does not prove lost superscience. It proves we underestimated ancient Greek precision. There's a difference between surprising and impossible. Out of place artifacts, or ooparts, are objects that seem to appear in the wrong time period. A digital watch in a Ming Dynasty tomb would be an oopart. So would a plastic bottle in a sealed Egyptian pyramid. The problem is that most claimed ooparts are nothing of the sort. They are misidentified, misdated, misunderstood, or simply fraudulent. The burden of proof for extraordinary claims must be extraordinary evidence. Take the London hammer found in Texas in 1936, encased in rock that looked millions of years old. Some claimed it proved ancient advanced humans, but the rock was not that old. It was a concretion, minerals deposited around the hammer over decades, not eons. Soluble minerals in groundwater created the illusion of ancient stone. The hammer itself is probably from the 1800s, mystery solved through chemistry, not imagination. The Ica stones of Peru tell a different story. Thousands of carved stones showing dinosaurs, surgery, and advanced technology. Farmer Basilio Ushuja claimed to find them in caves. Tourists bought them eagerly. Museums displayed them proudly. Then Ushuya admitted he made them himself with dental drills and shoe polish. He sold fiction as history. People bought fiction as fact. This is why provenance matters desperately. Where exactly was the object found? Who found it? Under what circumstances? What is the chain of custody? Scientific verification requires answers to all these questions. An artifact without provenance is an orphan. It tells no reliable story. It proves nothing except that it exists. The internal skeptic must be ruthless here. Independent laboratories must verify dates. Multiple methods must agree. Radiocarbon, thermoluminescence, potassium argon, each has limitations, but together they constrain possibilities. Peer review must confirm interpretations. Reproducible methods must be documented. One amazing find means nothing without this framework. Consider the Klerksdorp spheres from South Africa. Metal-looking balls found in 3 billion-year-old rock. Some claim they are too perfect to be natural, evidence of ancient technology, but mineralogists recognize them immediately. They are concretions of pyrite and goethite. Natural processes create spheres when minerals precipitate in sediment. No mystery, no ancient civilization, just chemistry and time. Even genuinely puzzling artifacts usually have mundane explanations. The Baghdad battery is a ceramic jar with copper and iron elements from 2,000 years ago. Some claim it was an electric battery, but it was more likely used for storing scrolls. The metal elements show no wear from electrical use. No wires have been found. No devices that would need batteries. Correlation is not causation, yet occasionally, genuinely anomalous objects appear. The Aiud artifact from Romania is aluminum-like but found with mastodon bones. Aluminum requires electrolysis to extract. That technology is only 200 years old. But mastodons died out 10,000 years ago. Laboratory analysis shows unusual composition, 12 different elements, not quite like any known alloy, contamination, misidentification, or something else. The jury is still out. This is how science should work. Anomalies deserve investigation, not worship or dismissal, but investigation means rigorous testing, not wishful thinking. Most ooparts dissolve under scrutiny. The few that remain puzzling need more data, not wild theories, Absence of explanation is not evidence of ancient superscience. It is evidence that we need better analysis. The real danger with OOPArts is selection bias. Hundreds of questionable artifacts get promoted. The 99% that get explained are forgotten. The 1% that remain mysterious get recycled endlessly. This creates an illusion of overwhelming evidence, but it is really just the same few cases repeated. Echo chambers amplify uncertainty into false certainty. Chemistry tells clearer stories than gadgets. Isotope ratios do not lie. Elemental composition is harder to fake. Molecular structure reveals origin. If our ancient advanced civilizations existed, their chemistry would be more convincing than their artifacts. A synthetic polymer from 100,000 years ago would revolutionize our understanding. A carved stone just raises questions. The problem with OOPArts is not that they challenge timelines. Good challenges improve science. The problem is that most are not good challenges. They are mistakes, frauds, or misunderstandings dressed up as mysteries. Real evidence would not be ambiguous. It would be overwhelming. Multiple artifacts, clear context, reproducible analysis, convergent evidence. That is what we need. Not scattered maybes, but systematic proof. We keep looking for metal tools. But what if they needed none? Imagine a city that grows like a forest. Buildings made from modified trees, bridges woven from engineered vines, tools shaped from hardened fungus, power drawn from hot springs and tidal flows. No mines, no smelters, no smoke. When the city dies, it returns to soil within decades. Would we recognize its ruins after 100,000 years? Would we recognize them as ruins at all? This is not fantasy. This is engineering with different materials. The tensile strength of spider silk exceeds steel. Bamboo's strength-to-weight ratio matches aluminum. Fungal mycelium can be grown into precise shapes and hardened into materials stronger than concrete. Nature already makes better materials than many of ours. We just insist on making our own. A civilization that mastered biotechnology would leave almost no traditional archaeological traces. Their buildings would decompose like fallen trees. Their tools would crumble like old bones. Their roads would become soil layers. Even their writing might be encoded in DNA or grown into seed patterns. Everything would return to the carbon cycle. Dust to dust, by design. Geothermal energy requires no fossil fuels. Iceland powers 90% of its homes with geothermal today. Yellowstone alone could power the entire western United States. If ancient people settled near hot springs and volcanic regions, they had unlimited clean energy. No coal ash, no carbon spike, no industrial signature, just heat from the earth, leaving no trace when the machinery stops. Tidal power is equally clean and far more predictable than wind or solar. The Bay of Fundy sees 50-foot tides twice daily. Enough energy flows through that bay to power cities. Wooden turbines in tidal channels would generate power, then rot away completely. The only evidence might be unusual erosion patterns, easy to mistake for natural processes, but the skeptic must speak. Even biotechnology changes landscapes. Agricultural fields alter soil chemistry. Irrigation changes water tables. Foot traffic compresses earth. Large populations modify pollen distributions. These changes persist in sediment cores. If a biological civilization existed, we should find anomalous soil layers, unusual nitrogen levels, Imported species. Traces remain even when structures vanish. Consider what we know about terra preta in the Amazon. This super fertile black soil was created by ancient peoples, adding charcoal, pottery shards, and organic waste to normal soil. It remains distinctly different after 500 years, still more fertile, still full of unusual microbes. If people can accidentally create permanent soil changes, imagine what intentional bioengineering might leave behind. The social organization of such a civilization might be radically different too. Without mining, they would not need to control mineral deposits. Without metals, they could not hoard wealth in vaults. Their economy might be based on knowledge and living systems rather than objects, seeds, breeding pairs, microbial cultures, wealth that reproduces itself but cannot be stolen easily. Their architecture would follow different principles. Instead of fighting the nature with concrete and steel, they would guide nature into useful forms. The Khasi people of India already do this, growing bridges from rubber tree roots. These bridges strengthen over time instead of weakening. They last centuries with minimal maintenance. They are alive. Writing and data storage would take new forms. DNA can store vast amounts of information. 1 gram of DNA can hold 700 terabytes of data. It lasts thousands of years if kept cool and dry. A civilization might encode its entire knowledge base in the genomes of symbiotic organisms, trees that carry libraries in their seeds, bacteria that remember mathematical proofs, information that reproduces itself. The objection always comes. Where's the evidence? But that is exactly the point. A civilization built from living materials would leave evidence we do not recognize as artificial. We look for right angles and metals. Nature provides curves and carbon. We search for machines and monuments. They might have left ecosystems and soil layers. Marine biologist Jeremy Jackson suggests that coral reefs might preserve evidence better than we think. Corals incorporate materials from their environment into their skeletons. If ancient people worked near reefs, traces might be locked in coral cores, unusual isotopes, synthetic molecules, micro artifacts. But we would need to look at 1,000-year-old coral with new eyes. The quiet technology leaves quiet archives. A wooden water wheel rots to nothing. A steel turbine leaves rust stains for millennia. Which is more advanced? The one that lasts, or the one that returns cleanly to nature? We assume permanence equals progress. But perhaps the opposite is true. Perhaps the most advanced technology is the one that leaves no scar. This is thought experiment, not established fact. We need evidence. Soil anomalies, genetic traces, chemical signatures, but we also need imagination. If we only look for civilizations like ours, we will only find civilizations like ours. The absence of metal cities does not mean the absence of sophisticated minds. Their cities would not reach skyward. They would spread like gardens. How far can memory travel without writing? Aboriginal Australians have stories about sea level rise from 7,000 years ago. These stories describe islands that formed, specific valleys that flooded, and coastlines that vanished. When the scientists check these oral histories against geological data, they match 7,000 years, 350 generations, memory traveling by voice alone. This tells us something profound. Complex societies do not need cities or writing to preserve knowledge. They need effective systems for transmitting information across generations. Songs, stories, rituals, star maps. These are technologies, just as much as computers or books. They store data in human minds instead of external objects. When the system works, it can preserve information for millennia. Consider the Polynesian navigators. They crossed thousands of miles of open ocean without instruments. They memorized the positions of 220 stars. They felt ocean swells reflecting off invisible islands. They recognized clouds that formed over land beyond the horizon. This knowledge passed from master to student through years of training. No books, no charts, just memory, structured and reinforced through ritual. A distributed civilization might organize around seasonal gatherings rather than permanent cities. The Kumbh Mela in India shows this is possible. Every 12 years, millions gather at specific river confluences. They trade, they teach, they perform rituals, then they disperse. Between gatherings, knowledge travels with people. The gathering site might show little permanent structure, but the social structure persists. We must be careful here. Oral histories are not perfect recordings. They change with each telling. Details shift. Metaphors replace facts. What starts as history becomes myth. We can use oral traditions to guide research, but not as standalone proof. They tell us where to look, not what we will find. Cross-checking against physical evidence is essential. The indigenous peoples of the Pacific Northwest developed complex societies without agriculture. They had ranked social systems, specialized crafts, long-distance trade, monumental art, population densities similar to agricultural societies, all based on salmon runs and cedar forests. Their potlatch ceremonies redistributed wealth across entire regions. Power came from giving, not hoarding. When Europeans arrived, they could not understand societies that burned wealth to gain status. Star knowledge preserves differently than we might expect. The Dogon people of Mali have astronomical traditions that include details about stars invisible to the naked eye. Some researchers claim this proves ancient advanced technology. Others point out that the details match what French anthropologists knew in the 1930s. Contamination from researchers is more likely than ancient telescopes, but the fact that such knowledge can be preserved orally for any length of time is remarkable. Ritual creates redundancy in memory systems. The same information gets encoded in songs, dances, stories, and ceremonies. If one fails, others preserve the knowledge. The Inca used quipu, knotted strings, to record information. But they also had memory specialists called quipucamayaks who memorized what the knots meant. The physical record and human memory reinforced each other. When the Spanish destroyed the quipas, the knowledge died with the specialists. 100,000 years ago, social organization might have looked nothing like ours. No nations, no armies, no corporations. Perhaps networks of kinship extending across continents. Perhaps seasonal cycles of gathering and dispersal. Perhaps age-based societies where knowledge passed through initiation stages. Without writing to freeze social structures, they might have been fluid, adaptive, constantly reorganizing. Teaching through song embeds information in melody and rhythm. The Australian song lines map the entire continent. Each landmark has a verse. Sing the song, walk the land. The song is map, history, and law combined. Children learn by walking and singing with elders. The knowledge is literally grounded in the landscape. As long as the land exists, the memory system works. But what happens when the landscape changes, when sea levels rise and coastlines flood, when ice covers familiar territories, when rivers change course? The memory system breaks. The songs no longer match the land. Within a few generations, accurate information becomes incomprehensible metaphor. This might explain flood myths worldwide. Real floods, remembered in story, disconnected from geography. Catastrophic events would affect distributed societies differently than concentrated ones. A city can be destroyed in a day. A distributed network of communities might lose nodes but survive overall. Like the internet routing around damage, some knowledge would be lost. Core knowledge might persist. The society continues in altered form. This raises a troubling thought. If advanced societies existed 100,000 years ago, organized in ways we do not recognize, their collapse might also look different. Not ruins and ash, just gradual simplification. Knowledge becoming ritual, ritual becoming tradition, tradition becoming mystery, until only fragments remain, preserved in stories no one quite understands. The skeptic notes that this is speculation built on speculation. We need evidence of these alternative organizations, settlement patterns, trade networks, genetic mixing. But if the organization was truly different, we might not recognize the evidence. We look for hierarchy because we are hierarchical. We look for centers because we centralize. What if they did neither? Memory without monuments, culture without cities. Now we ask how such worlds end. 74,000 years ago, Toba erupted. A supervolcano in Indonesia that ejected 2,800 cubic kilometers of ash. That is enough to bury all of India 3 meters deep. Global temperatures dropped by 3 to 5 degrees Celsius within months. The volcanic winter lasted 6 to 10 years. Some researchers think human population dropped to fewer than 10,000 individuals. Others dispute this bottleneck, but no one disputes that Toba changed the world. This is what sudden catastrophe looks like in the geological record. A layer of ash spread across 3 continents, a sulfur spike in ice cores, a carbon crash as photosynthesis failed, then silence, fewer stone tools, fewer occupation sites, fewer signs of life. If an advanced society existed near Toba, they would have faced starvation within weeks. No amount of knowledge saves you when the sky turns black and stays black, but we must be careful with Toba. The genetic bottleneck is debated. Some populations far from the eruption show no signs of decline. Africa had multiple refuge areas. The catastrophe was regional, not uniform. This is important. We tend to imagine single devastating blows. Reality delivers multiple smaller hits. Death by 1,000 cuts. Not one executioner's stroke. Climate whiplash might be worse than steady cold. The Younger Dryas shows this pattern. 12,900 years ago. Temperatures plummeted 8 degrees Celsius in less than a decade. Forests became tundra. Then, 1,300 years later, temperatures jumped back up just as fast. Any society adapted to the cold would have faced devastating floods and ecological collapse. Survival required constant adaptation. Asteroid impacts add another layer of risk. We know of at least 190 confirmed impact craters on Earth. Most are small, some are not. The Chicxulub impact killed the dinosaurs. But smaller impacts happen more often. Tunguska in 1908 flattened 2,000 square kilometers of forest. That is larger than London. If it had hit London, 6 million would have died instantly. These events cluster randomly. You might get 3 in a century, then none for 10,000 years. The real danger is compound disasters, an asteroid impact during an ice age, a supervolcano during a drought, a pandemic when trade networks are stressed. Each alone is survivable. Together, they overwhelm any society's resilience. We see this in smaller scales throughout history. Rome faced plague, invasion, and economic collapse simultaneously. The Maya faced drought, war, and soil depletion together. The Bronze Age collapse involved multiple societies failing within decades for interconnected reasons. Self-destruction adds to natural risks. Any society capable of advanced technology can destroy itself, not just through war. Though war is always possible, environmental destruction, resource depletion, social breakdown. The more complex the society, the more ways it can fail. We are living this experiment now. Climate change, nuclear weapons, biological engineering. Each advancement creates new ways to end. Ocean chemistry tells stories of past catastrophes. The Permian extinction, 252 million years ago, killed 96% of marine species. The ocean became acidic and anoxic. Hydrogen sulfide gas bubbled up from dead zones. The sky turned green. The air smelled of rotten eggs. This was not instant, it took thousands of years. But once started, it could not be stopped. Disease leaves few traces, but can end civilizations overnight. When smallpox reached the Americas, it killed 90% of the indigenous population. Entire cultures vanished before Europeans saw them. We know they existed only from abandoned cities and second-hand accounts. If something similar happened 100,000 years ago, we would find only the sudden absence. Fewer sites, smaller sites, then nothing. The skeptic demands precision here. Each catastrophe hypothesis needs testing. Volcanic ash can be chemically fingerprinted to specific eruptions. Impact craters can be dated precisely. Climate changes leave isotope signatures, but connecting catastrophes to specific cultural changes requires careful chronology. Did the society end because of the disaster, or were they already gone when it happened? Correlation needs mechanism to become causation. Yet catastrophes do not always mean extinction. Humans survived Toba. We survived the Younger Dryas. We survived ice ages and warm periods. What dies is complexity. Cities become villages. Villages become camps. Writing stops. Trade ends. Knowledge simplifies to essentials. Fire, food, shelter, stories. The basics persist. The elaborations vanish. Recovery takes time. After the Bronze Age collapse, 500 years passed before similar complexity returned. After the fall of Rome, 1,000 years in some regions. If a society fell 100,000 years ago, they had 90,000 years to recover before the next catastrophe. But each recovery might follow different paths, different technologies, different social structures, different values. This is the cycle: rise, complexity, crisis, collapse, simplification, recovery, rise again, but never quite the same. Each iteration loses some knowledge and gains other insights. Libraries burn, oral traditions persist, mathematics vanishes, star knowledge survives. The thread continues, but the pattern changes. After the shock, only fragments remain. But which fragments matter most? The last person who knew how to read Roman concrete recipes died sometime in the 6th century. No drama, no disaster. Just an old engineer whose apprentice never quite learned the formula. Within a generation, the knowledge was gone. For 1,000 years, humans built inferior concrete while superior Roman examples stood all around them. This is how complex systems fail. Gradually, then suddenly, then completely. Specialization is the first casualty of decline. A thriving society supports potters, mathematicians, astronomers, and poets. A struggling society needs farmers and fighters. When trade networks break, specialists become generalists or starve. The potter learns to farm, the astronomer tends sheep. Within 3 generations, no one remembers why the old man watched stars so carefully. Knowledge becomes nostalgia, then folklore, then nothing. Easter Island tells this story, though the details remain contested. The Rapa Nui people built nearly 1,000 massive stone statues. Then they stopped. Earlier interpretations blamed ecological collapse. They cut down all the trees. Soil eroded. Population crashed. Civilization ended. But newer evidence suggests a different story. European disease killed 90% of the population. Slavers took many survivors. The society did not collapse. It was murdered. The truth probably includes both narratives. Resources were stressed before Europeans arrived. But the society was adapting, not collapsing. They had shifted to new agricultural methods. Population was stable, not crashing. Then external shock hit an already stressed system. This nuance matters. Collapse is rarely simple. Multiple causes compound. The story we tell depends on where we start counting. When complexity fails, humans default to older patterns. Cities empty. Villages persist. Writing stops. Stories continue. Metal tools break. Stone tools return. This is not always regression. Sometimes it is adaptation. The classic Maya abandoned their cities but continued as rural farmers. Were they diminished or freed? The answer depends on your values. Knowledge transforms as it simplifies. Technical manuals become craft traditions. Craft traditions become family secrets. Family secrets become mysterious rituals. Each generation loses precision but might gain meaning. The formula for Roman concrete was lost. But the idea that Romans built eternal structures became myth. The myth inspired later builders even without the formula. Here the skeptic must intervene. We project our assumptions onto incomplete evidence. When we see abandoned cities, we assume catastrophe. But cities are often abandoned peacefully. Angkor Wat was not destroyed. The capital moved. Petra was not conquered. Trade routes shifted. Absence of people does not mean presence of disaster. Multiple hypotheses must be tested. Independent evidence must converge. The Indus Valley civilization shows how quietly complexity can end. 4,000 years ago, they had cities, sewers, and standardized weights. Then they stopped. No invasion evidence, no mass graves, no clear catastrophe. Cities were slowly abandoned. Writing disappeared. Population dispersed into villages. The only clear signal is absence. Fewer artifacts, smaller settlements. Then archaeological silence. Loss happens in stages. First, luxury goods disappear. No more imported wines or elaborate jewelry. Then specialized tools vanish. No more precision instruments or complex machines. Then basic infrastructure fails. Aqueducts clog, roads crack, bridges collapse. Finally, even simple maintenance stops. Roofs leak, walls crumble. Nature reclaims, but humans persist with less. The Dark Ages were not uniformly dark. Local knowledge flourished while libraries burned. Herbal medicine continued while medical texts were lost. Seasonal wisdom persisted while calendars were forgotten. The spectacular vanished. The essential endured. Different knowledge, not no knowledge. Memory finds new vessels. Children's songs preserve history. The song, Ring Around the Rosie, might remember the Black Death. London Bridge is falling down, might recall Viking attacks. We sing these to toddlers, not knowing we transmit ancient trauma in nursery rhymes. If manuals burn, lullabies might teach what matters. Consider what survives longest. Not books or buildings, not art or equations. Stories survive. Gods survive. Fears survive. The fear of flood appears in every culture. The memory of paradise lost is universal. These might be psychological archetypes, or they might be cultural memories of real events, preserved in the only medium that lasts, human memory, refreshed each generation through telling. A slow collapse from 100,000 years ago would leave almost nothing we recognize. The cities would be dust. The tools would be rust. The books would not even be dust. Only the most essential knowledge would pass through the bottleneck. How to make fire, how to find water, how to read seasons, how to remember. The survivors would not be primitive. They would be simplified. There is a difference. Primitive never had complexity. Simplified once did, but adapted to its loss. The knowledge might be gone, but the capacity remains. Given time and stability, complexity could return. Different, but not unprecedented. This is perhaps the most unsettling thought. If advanced societies rose and fell before us, their descendants might be us. We might carry their genes, their stories, their fears, but not their knowledge. We might be the children of collapse, slowly rebuilding what was lost, not knowing it was ever found. Knowledge dissolves. Bodies remain. What code persists? DNA has a half-life of 521 years. After 10,000 years, the fragments are too short to read meaningfully. After 100,000 years, there is essentially nothing left to sequence. This is why we will never clone dinosaurs. It is also why finding direct genetic evidence of ancient advanced humans is nearly impossible. The code dissolves while the carriers keep walking. But living DNA tells different stories. Every human carries about 3 billion base pairs of genetic information. Hidden in that code are traces of everyone who came before. Neanderthal genes for immune function, Denisovan genes for high-altitude adaptation. Ghost populations we know only from statistical shadows in modern genomes. If an advanced society existed 100,000 years ago, and any survived to have children, we carry their echoes. The problem is distinguishing signal from noise. Genetic admixture blurs over time like cream stirred into coffee. After 1,000 generations, specific markers disperse across entire continents. What started as a distinct population becomes a faint statistical signature. Labs can detect that something happened. They cannot always say what. Modern techniques are powerful but imperfect. We extract DNA from ancient teeth and bones. We amplify it using polymerase chain reaction. We sequence it and compare to modern genomes. But contamination haunts every sample. One skin cell from an excavator can ruin results. Temperature changes degrade preservation. Bacteria replace human DNA with their own. What looks like an ancient genome might be mostly modern contamination plus bacterial noise. Consider what we have learned from good samples. The Denisovans are known from a finger bone and a few teeth found in a Siberian cave. From this, we know they interbred with humans at least twice, once in Asia, once in Oceania. Different populations, different times. Their genes persist in billions of living people, but we know almost nothing about their culture, technology, or society. Genes tell us they existed. Genes do not tell us how they lived. Population bottlenecks leave genetic scars. When numbers drop below a few thousand individuals, genetic diversity crashes. We see this in cheetahs. Every cheetah is so genetically similar they can accept skin grafts from any other cheetah. Humans show bottleneck signatures too, one around 74,000 years ago, possibly from Toba. Another around 195,000 years ago, cause unknown. If civilizations collapsed at these points, the genetic evidence would look exactly like what we see. But genes are not culture. A population can lose every trace of advanced knowledge while keeping their DNA intact. The children of Rome became medieval farmers. Same genes, different world. If ancient advanced peoples suffered similar collapse, their descendants might be us, carrying the hardware but missing the software, the capacity for civilization preserved, the specific civilization lost. Small founding populations create drift. When groups separate, random genetic changes accumulate. Over time, populations diverge, but culture can maintain connections that genes do not show. Trade, seasonal gatherings, ritual exchanges. Two populations might be genetically distinct, but culturally united, or genetically similar but culturally alien. Genes are one thread in the rope, not the whole rope. Laboratory methods improve yearly. Ancient DNA from soil, environmental DNA from sediments, protein sequencing from fossils too old for DNA. Each technique opens new windows, but windows into biology, not technology. We can trace population movements. We cannot trace ideas. We can date genetic splits. We cannot date when someone invented writing or metallurgy or philosophy. The skeptic notes critical limitations. Most ancient DNA comes from cold climates where preservation is better. This biases our picture toward northern populations. Tropical civilizations are genetically invisible. Ethics matter too. Indigenous peoples often oppose genetic sampling of ancestors. Their consent matters more than our curiosity. Open data and reproducible methods are essential. Too many studies make claims from proprietary data no one can verify. Mutation rates calibrate molecular clocks, but mutation rates vary between species, between populations, between genes. A clock running fast makes recent events look ancient. A clock running slow makes ancient events look recent. Confidence intervals span thousands of years. Precision is an illusion at deep timescales. Yet patterns emerge from uncertainty. All non-African populations descend from a small group that left Africa around 70,000 years ago, maybe a few hundred individuals. This does not mean Africa was empty or primitive. It means a tiny group had descendants who have survived while others did not. History is written by the reproductively successful, not the technologically advanced. Here is what haunts me. We share 99.9% of our DNA with all other humans. The differences that seem so important to us are trivial genetically. If ancient advanced peoples existed, they were essentially us. Same brains, same hands, same capacity for love and language and loss. Their knowledge might be gone, but their biology persists in every child born today. Genes whisper in frequencies we barely hear. Now let us hear what stories shout. Every culture on earth tells of a great flood. Mesopotamians wrote of Utnapishtim. Hebrews spoke of Noah. Greeks remembered Deucalion. Hindu texts describe Manu. The Ojibwe tell of Nanabojo. Chinese records speak of Gunyu. Different names, different details. Same water rising, same world ending, same few survivors. Is this convergent mythology or convergent memory? Myths compress data like zip files, compress documents. Details are lost, but patterns survive. 1,000-year dynasty becomes a single king. A century of raids becomes one great battle. A slow sea level rise becomes a single deluge. The compression is lossy, but not random. Real events seed the stories, even as facts transform into metaphor. Australian Aboriginal stories describe the flooding of Port Phillip Bay near modern Melbourne. They tell of land that connected islands, of kangaroos grazing where fish now swim. Geologists confirm the bay flooded 7,000 years ago, when rising seas broke through the heads. The stories were right. Oral tradition preserved accurate geography for 350 generations. If stories can last 7,000 years, why not longer? The Black Sea deluge hypothesis offers another correlation. Until 8,000 years ago, the Black Sea was a freshwater lake. Then Mediterranean waters burst through the Bosporus. The lake rose 150 meters. Farmland became seafloor in perhaps less than a year. If this happened, everyone who escaped would carry trauma. Every culture they found it would remember. The details would change, but the water would remain. We must be extremely careful here. Correlation is not causation. Floods are common human experiences. Every river valley floods. Every coast sees storms. Convergent stories might reflect convergent experiences, not shared memory. Finding a flood layer that matches a flood myth proves nothing. Floods happen. Myths happen. Sometimes simultaneously, sometimes not. But some correlations are too specific to ignore. Tamil traditions speak of Kumari Kandam, land south of India swallowed by the sea. Geology shows the Indian Ocean has indeed risen over the past 10,000 years. The Sunda Shelf was dry land. Now it is seafloor. The match is not perfect. Myths speak of cities and kingdoms. Geology shows gradual submersion. But the core memory might be real. Plato's Atlantis haunts these discussions. He described an advanced island civilization destroyed by flood 9,000 years before his time, about 11,600 years ago. The end of the Younger Dryas, when massive ice dams broke and glacial lakes emptied catastrophically. The timing is suspicious, but Plato was making a philosophical point about hubris, not writing history. Yet he claimed Egyptian priests as his source. Was he inventing or transmitting? Memory mutates with each telling. The game of telephone writ large across millennia. But some elements resist change. Water, fire, sky falling, earth shaking. These experiences are so traumatic, they burn into collective memory. The specifics blur, but the fear remains sharp. We still dream of drowning, though we live far from seas. Native American stories tell of mountains of ice and valleys carved by giant beavers. Geologists see glaciers and glacial floods. The correlation is clear even through metaphor. The Missoula floods happened 15,000 years ago. Walls of water 300 meters high. Boulders the size of houses carried like pebbles. Anyone who saw this would never forget. Their children's children's children would still be telling the story. The skeptic demands rigor. Post hoc pattern matching is easy. Take any myth, find any geological event, declare connection. This is bad science. Good correlation requires specific predictions. If this myth is memory, then we should find evidence here, not there. Then dig, test, replicate. Most correlations will fail. The few that survive scrutiny might be real. Volcanic memories persist too. The Klamath people of Oregon tell of the war between Lau and Skell. The mountain exploded. Darkness covered the land. Lau fell into the pit that became Crater Lake. Geologists date the Mount Mazama eruption to 7,700 years ago. The story is accurate, the timeline matches, the details correspond. Memory dressed as mythology. But stories also point where we have not looked. Sundalen myths speak of vast lands now underwater. Doggerland stories tell of hunting grounds beneath the North Sea. If we took myths as maps and searched where they point, what would we find? Not Atlantis, perhaps, but something. The stories might be wrong about what, but right about where. The real lesson is humility. We dismissed oral tradition as fantasy. Then we found it preserved accurate information for millennia. We are pattern-seeking animals telling stories to make sense of chaos. But sometimes the chaos was real, and the stories remember, not perfectly, not literally, but genuinely. If stories point, we should drill carefully. The past might answer. If tomorrow we found undeniable evidence of a civilization from 100,000 years ago, what would happen? Not in Hollywood, in real science. The answer is less dramatic and more important than you might think. First would come doubt, then verification, then very careful words. Science does not rewrite history on Tuesday because of what someone found on Monday. The process would be methodical. Pre-register the hypothesis before testing. Document every step. Photograph every layer. Sample in triplicate. Send duplicates to independent labs. No lab knows what the others found. Compare results. If they match, proceed. If they diverge, start over. This is not skepticism. This is method. Method protects truth from wishful thinking. Open data would be essential. Raw measurements published immediately. Not interpretations. Not narratives, just numbers. Let anyone check the math. Let critics find flaws. Science advances through falsification, not confirmation. The goal is not to prove the hypothesis right. The goal is to fail to prove it wrong despite sincere effort. Consider how we would test a claimed 100,000-year-old synthetic polymer. First, confirm it is synthetic. Natural processes create complex molecules. Document why this one requires intelligence. Second, date it accurately. Multiple methods. Multiple samples. Error bars included. Third, check provenance. Where exactly was it found? What surrounded it? Who handled it? Every link in the chain matters. Peer review would be brutal but necessary. Experts would demand answers. Why this interpretation, not that one? How do you exclude contamination? What predictions does your hypothesis make? Where else should we find similar evidence? Anonymous reviewers would tear the work apart, not from malice, but from duty. Extraordinary claims require extraordinary scrutiny. The skeptic's voice would be loudest and most valuable. Every possible alternative explanation must be tested. Could natural processes create this pattern? Could modern contamination explain these molecules? Could dating errors shift the timeline? The burden of proof lies entirely on those making the claim. Negative results must be published alongside positive ones. Public communication would require extreme care. Media wants sensation. Science needs precision. The headline, "Lost a Civilization Found," sells papers. The accurate statement, "Anomalous chemical signature in sediment layer requires further investigation," does not. But accuracy matters more than attention. False hopes waste resources. Premature claims destroy credibility. If evidence survives scrutiny, textbooks would change slowly. First, a footnote about ongoing research, then a paragraph about new findings. Eventually, perhaps a chapter rewriting the timeline. But this takes years, sometimes decades. Science is conservative by design. It resists change until change becomes undeniable. This frustrates revolutionaries but protects against delusion. The real impact would be philosophical more than practical. We would not suddenly gain ancient technology. We would gain ancient perspective. The knowledge that others reached heights and fell would change how we see ourselves. Not unique, not permanent, not the first, possibly not the last. This humility might be the greatest gift from the past. Interdisciplinary cooperation would become essential. Archaeologists would need chemists. Geologists would need geneticists. Computer models would merge with fieldwork. The question is too large for any single discipline. Only convergent evidence from multiple fields could confirm such a discovery. Silos would have to fall. Here is what matters most. The method must outlast the discovery. Even if we found proof of ancient advancement, the way we verified it would be more important than what we found, because method is what separates knowledge from belief. Method is what lets us build on truth rather than mythology. Method is memory that does not mutate. Finding evidence would also mean accepting absence. If we searched systematically and found nothing, that too is valuable. Negative results constrain possibilities. They tell us where not to look and what not to expect. Science advances through eliminated possibilities as much as confirmed ones. Absence of evidence, properly documented, becomes evidence of absence. The timeline would not change overnight. It would shift gradually as evidence accumulated. Each discovery would move the boundary slightly, like watching sunrise. You cannot point to the moment darkness becomes light, but eventually the day is undeniable. This is how scientific revolutions actually happen. Slowly, carefully, irreversibly. Method outlasts myth. But what outlasts us? The deepest lake sediments remember 1,000,000 years. Ice cores hold 800,000. Deep ocean clay preserves even longer. These are Earth's quiet archives, places where time moves slowly and evidence accumulates grain by grain. If we want our own civilization to leave readable traces, we should learn from these natural libraries. Build where Earth edits least. Store what matters most. Teach what must survive. Our cities will not last. New York will be forest or seafloor within 10,000 years. But choices we make today about materials and methods determine what traces remain. Concrete with fly ash creates distinctive markers. Nuclear waste generates isotope signatures lasting millions of years. Plastics become microparticles in sediment layers. We are writing our story in chemistry, whether we intend to or not. Build for repair, not permanence. The Roman pantheon has survived 2,000 years because people maintained it. Abandoned. It would be rubble by now. Structures that can be fixed with simple tools last longer than those requiring specialized knowledge. A stone wall can be rebuilt by anyone who can lift rocks. A fiberglass dome requires chemistry. No village remembers. Store information redundantly. The Rosetta Stone worked because it repeated the same text in 3 scripts. When knowledge exists in only one form, it dies with that medium. Carve important things in stone. Encode them in songs. Build them into landscape. Make them into rituals. What matters enough to preserve deserves multiple vessels. Materials should age honestly. Bronze develops patina but remains bronze. Iron becomes rust and disappears. Glass shatters, but the fragments last forever. Plastic pretends permanence, then crumbles to poison. Choose materials that degrade gracefully or not at all. Let future archaeologists read your story clearly, not guess through toxic residue. The skeptic notes harsh trade-offs. Preservation costs energy. Redundancy costs resources. Simple technology means accepting limits. We cannot have consumer convenience and archaeological clarity. We cannot build disposable culture and leave readable records. Every choice has consequences across deep time. Most of those consequences we will never see. Teaching by song seems primitive, until you realize songs outlast libraries. The Aboriginal Australians preserved navigation for 50,000 years without writing. Every generation refreshed the memory. Every child became a library. When the elders died, the knowledge lived. When we digitize everything, what happens when the power stops? Consider what we want to communicate across time, not technical manuals. Those become obsolete, not political positions. Those become incomprehensible. What matters are constants. This place floods. That mountain explodes. These plants heal. Those animals return each spring. Knowledge tied to landscape survives because landscape endures. The nuclear waste warning problem teaches humility. How do you warn people 10,000 years from now about buried poison? Language changes. Symbols shift meaning. Hostile architecture becomes sacred. The solution might be stories. Myths of cursed ground. Tales of sleeping death. Fear embedded in culture. Refreshed through retelling. But we also build accidentally. Every mine becomes a geological anomaly. Every dam changes sediment patterns. Every farm alters pollen records. Future scientists will read our presence in disrupted layers and shifted chemistry. The question is not whether we leave traces, but whether those traces tell true stories. Intervention requires replication. If we deliberately create time capsules or monuments meant to last, we must create many. One pyramid might be missed or misunderstood. 100 pyramids make a statement, but this assumes future finders think like us. They might see patterns where we intended none and miss messages we thought obvious. The real lesson from imagining past civilizations is recognizing future ones. Someone will come after us. They will dig through our ruins and wonder what we meant. They will find our plastic and ponder our choices. They will decode our chemistry and judge our wisdom. We are creating their archaeology right now. How do we wish to be remembered? As the civilization that burned everything burnable? As the species that poisoned its own nest? Or as the generation that learned from deep time and chose differently? The choice is ours, but the judgment is theirs. We write our fossil record every day in choices that seem small but accumulate into layers. Memory is what we choose to repeat. Silence is what we allow to fade. The future will know us by what persists, not what we promised. Our plastic will outlast our philosophy. Our isotopes will outlive our ideologies. Choose wisely. Time remembers chemistry, not intentions. We are tomorrow's mysterious ancients. Picture yourself standing on a hill that was once seafloor. Below you, a drowned plain stretches beneath waves that rose 7,000 years ago. In your mind, drain the water. See the valleys, the rivers, the places where people might have lived. Now let the water return. This is how Earth keeps secrets, not by hiding them, by drowning them in plain sight. We have traveled together through 100,000 years of possibility, through ice and ash, through chemistry and myth, through what we know and what we cannot know. The question we asked was never really about them, those hypothetical ancients. It was about us, about how knowledge survives or does not, about what time remembers and what it forgets. Thank you for taking this journey into deep time, for holding uncertainty without discomfort, for imagining possibilities without requiring proof. This kind of thinking matters. It teaches humility about our place in time. It reminds us that absence of evidence is not evidence of absence. It whispers that we too will one day be mysteries. If these ideas sparked curiosity, consider subscribing. We explore more questions at the edge of knowing, not to find answers, but to find better questions. The past is mostly silence, but silence is not empty. It is full of things we have not learned to hear. You can rest now. The questions will keep. Time is patient with its secrets. Tomorrow you will walk on ground that was once something else. You will breathe air that dinosaurs breathed. You will carry atoms that were once in stars. You are already part of deep time. You always were. Perhaps one day, someone will find that synthetic polymer or that impossible isotope. Perhaps they will read these very words in some unimaginable archive. Perhaps they will wonder who we were and what we dreamed. Until then, we have only questions and the courage to ask them. Sleep well, time traveler.